Hello guys, I hope you are having a good time. Today we are going to start fluid mechanics, one of the most important subjects of mechanical engineering. My name is Rahul. You are watching Smart Tech Ed, where you can expect the best. So guys, without any delay, let's start our video. Moving on to another topic, that is thermodynamic properties. Fluid consists of both liquid and gases, but gases are compressible fluids, and hence thermodynamic properties play a very important role. With the change of pressure or temperature, gases undergo large variation in density. Isothermal process. When change in density of fluid occurs at constant temperature, the relation between pressure and density is given by pressure upon density is equals to constant. For adiabatic pressure, if change in density occur with no heat exchange to and from the gas, the process is called adiabatic. If no heat is generated within the gas due to friction, the pressure density relation is given as P upon rho with the power K is equals to constant, where K is the ratio of specific heat of a gas at constant pressure and constant volume. Moving on to the further another topic, that is surface tension and capillarity. Surface tension is defined as the tensile force acting on the surface of the liquid in contact with a gas or on the surface between two immersible liquids such that the contact surface behaves like a thin membrane under tension. It is denoted by letter sigma. As you can see on the figure on the right hand side, in the figure the resultant force acting on a molecule A will be 0, but in case of molecule B and C, they are near the free surface and are acted upon by upward and downward unbalanced forces. Therefore, the resultant force will be downward. Thus, surface of the liquid will act as a thin membrane under tension. Moving on to another topic, that is expression for surface tension on liquid droplet. Let us suppose sigma is the surface tension. Pressure intensity of droplet is denoted by P. D is the dia of droplet. So the tensile force acting upon the circumference of a drop due to surface tension is given by sigma pi d. We mark it as our first equation. Pressure on the area is given by P into pi by 4 d square. We mark it as our second expression. Under equilibrium condition, our both expressions are equal. So we can say P into pi by 4 d square is equal to sigma pi d. From here we get the expression of pressure, that is P is equal to 4 sigma upon d. Moving on to the next topic, that is expression for a hollow bubble. As we know that bubble has two surfaces, that is an outer surface which is surrounded by the air, and there is an inner surface which is also surrounded by an air. So for that we say that P into pi by 4 d square is equal to twice of the sigma pi into d. From that we get the pressure equation as 8 sigma upon d. Moving on to the other topic, that is capillarity. Capillarity is defined as the phenomena of rise and fall of a liquid in a small tube as compared to the general level of fluid or liquid when a tube is held vertically in the liquid. The rise of liquid surface is called capillarity rise, and the fall in liquid surface is called capillarity depression. Moving on with the expression of capillarity rise, you can see the figure on our right hand side, where h is the height of the liquid in tube, sigma is the surface tension, theta is the angle between the liquid and glass tube, and rho is the density. Weight of liquid in tube is given as area into height into density into G, where pi by 4 d square into h into density into G. Vertical component of tensile force is given as sigma into circumference into cos theta, where sigma pi d cos theta. From equilibrium condition, pi by 4 d square into h into rho into G is equals to sigma pi d cos theta. From equating the two expressions, we get height is equals to 4 sigma cos theta upon rho gd. The value of theta between water and clean glass is taken as to be 0, hence the cos theta value is considered to be unity. So the expression reduced to be 4 sigma upon rho gd. Moving on to another expression, that is expression for capillarity fall. First, force in activity due to surface tension in downward direction is given by sigma pi d cos theta. We marked it as our first equation. Second, force is active upward and equals to intensity of pressure at a depth of h. So it is given by P into pi by 4 d square, where P is rho gh into pi by 4 d square. From equating 1 and 2 equations, we get our expression, that is h is equals to 4 sigma cos theta upon rho gd. The value of theta for mercury and glass tube is taken as 128 degree. So guys, that was it for today. We will be back with new videos on fluid mechanics. Till then, stay tuned and don't forget to like our video and subscribe to our channel and hit the bell icon to get the latest notification of our new video.